Good morning, boys and girls. Welcome back to the southern wing of the Stink Bug Works. Today, I don't have much to talk about. This is nearly complete. I'll go over it. We'll talk about these. Let's talk about gears for a while. You know, I've said time and time again, with modern brushless motors, you really don't need gears. And they kind of went out with round cells and brushed motors. And to that end, this gearbox was originally built for 2 brushed motors and ran in a boat with 8 round cells. I put 2 Speed 300 motors in this thing and ran them on 8 AR 800s in a shrunken down version of J. Turner's XS Cat. Now, the XS Cat was designed for car motors, and the design was foam sponsons that you sheeted with 64th plywood, and then you built a center section, and that's where all your electronics went, and the sponsons were just foam. You couldn't get anything in there. As a result of having the motors and the batteries in that small confined space there was a whole lot of, the whole boat was really light, but the electronics weighed a ton. So there was a whole lot of weight above the waterline. And in fact, way far above the waterline. And what that meant was the boat would go down the straits just as nice as could be. You'd go to turn and it would be a log rolling down the pond. So that boat never really went anywhere. But I kept the gear drive. In fact, what this was inspired by the Huey gear drive. This is a shrunken down Huey. In fact, this might even be a Huey part right here. But regardless, the Huey design had 2 motors running a central drive shaft, so that's what I had. And in fact, the Huey was vibration mounted. I put vibration mounts on this. Bingo. Well, this got me to thinking, and it's lo and behold, this 2030 motor has the same bolt pattern as a Speed 300. I could resurrect this thing if I wanted to someday with 2030 or even 2040 motors. So that's a project sitting in the back of my mind. The only place it would really serve a purpose is if I have a real low space, like in a Cat, where there's not much distance between the tunnel floor and the hatch. That's the only reason I could see for doing this. That's why a lot of boats have a big bubble for a hatch, is to give a place for the motor to live. This allowed the motor to lay flat. And back then, S-curves in your drive shaft were a common way to go. It eliminated cable whip. It did add a little more overall friction, but it eliminated cable whip. So, and this could have a home too. What amazes me is how smooth these things are. They're just incredibly smooth. This could find a home again in something. This little gear drive is pretty specific to this motor. You notice I had to notch this tube, this brass tube right in here to clear the motor. If I had smaller gears for whatever reason, the motor would crash with the tube. So I had to relieve the tube. On to this guy. I epoxied this little strip of carbon. It's 1 millimeter by 3 millimeters. This single little bit of carbon here just drastically increases the stiffness. Even this boat. And this boat's full of pore foam in the sponsons here. And even this boat has some flex. This boat has none. And it cost me twice this. It cost me twice nothing to run that across there. So that's just a huge structural increase at virtually no weight. But wait, or but wait, look at hell, boys and girls, look at hell. This thing's ready to go with one major exception and one minor exception. The minor exception, and I can live with it, is two things. One, I think this hole, I have it too far back. If I brought this hole forward, I could tilt this whole thing down a little bit and make it a little bit shorter and still maintain the angle of dangle. Number two is I used a real thin piece of carbon for this, and so it's got a little bit of flex. I mean, it's going to stay there, but who knows? It could vibrate. I could go down the road and it'd be going bzzzt, and that just wouldn't be cool. So I may use a heavier piece, shorten it up, use this as a template. Okay, let's go over what I've done. I'm going to start off with an Octura X series prop because they're good all-round props and you know what to expect from them. They're not going to leave you cavitating. I really want to try that, what is it, 2137. But those things don't always work. Sometimes they sit there and create foam. So that's that. I did not design the gear drive to take thrust loads. So I've installed a thrust bearing between my collet and the gear drive. So now the whole gear assembly takes all the thrust loads. And it transfers it directly to the boat right there. So that's all good. I've customized some jam foam. I've even glued together little blocks in some sort of transformer Lego man kind of shape. I've even marked them where they go. So I'm full of foam and ready to rock and roll. These batteries, you know, this C rating business, go to SMC's website and he'll talk about how battery companies use C rating and it really means nothing. What you want is an overall package rating and they give it to you there. You know, C rating is C rating. It doesn't mean as much as battery quality means. Now, as far as battery quality goes, these are nothing but the best of Chinese batteries, so go figure. So that's it. So we're running an Octura X37. I forget the gear ratio, but we're seeing about 3,500 RPM per volt here at the prop. I'll have to run the numbers on this. Oh, the big problem. The big problem is right here. I don't have a bellows. Now, when The United States and China got into this big urinating contest over who's going to charge who the highest tariffs. You know, all of a sudden, parts became hard to find. So I found a few. I ordered a few from several different vendors. I'm looking at tracking numbers. I may have some coming this week. I'm being generous when I say this week. So this will be seaworthy. It's ready to go. It's greased up. It's smooth like a baby's butt. And it's ready to rock and roll. So until then, boys and girls, jet out. Welcome back, boys and girls, to a special bonus feature. One of my viewers had asked a few videos back how I was going to mount the turn fin. There were some questions about it. So let's talk about what I did. Let's find a good pointer. This will make a good pointer. So I put 2 bolts from the inside. And I did that because the batteries are going in here and I don't want them slamming up against the end of some bolts. So I used hex bolts that had a low profile head and then bolted up this bracket, flipped it up and filled that space, you know, where the bolts are sticking up with epoxy and milled fiberglass. And now I have a nice smooth surface for the batteries to bang into, and nuts. I put nuts on to hold this bracket in place. Then there was some talk about what I'm doing with this support. And I did this on the American Spirit, and the full-size boats have been doing this as of recently. Because this takes all these loads. So this bracket only takes those loads and those loads. It doesn't take those loads, the bending loads. That's all taken up here. So what I've done is I've slotted the hole here, and I've slotted the hole this way here. So I can move it this way, I can move it this way. I have ultimate adjustability in my turn fin. Plus, since everything's straight, there's no curves in it, these are really easy to make. I think this is 32 thousandths stainless, and I have a little shear that will cut 32 thousandths stainless. So I can, 4 cuts and I have the thing made. And then this piece right here is just spot welded on. And so I spot weld a piece on, and now that I have a carbide mill, I can easily mill slots this way and this way in this stainless. Stainless is really hard stuff, but carbide is harder. So that's how I've done this turn fin. Oh, I didn't talk about this. I was originally planning on using a threaded rod with a nylock nut at this end, and I'd do the same thing as I did here. I'd bolt everything up and then pull up some epoxy and milled fiberglass over this nut. But I found I had a panhead Phillips screw that was long enough to do just that, and so I used that instead. So there you go. I have angle of dangle adjustment, I have up and down adjustments, I have to Somerset extent. A little bit of, well, not that much 4.5 because this limits it. I do need this because to allow for that. You know how that all goes. Anyway, now I can finally say jet out.